My name's Ryan Delahanty, and I have problem number 2 on this exam. The problem states, by means of a plate column, acetone is absorbed from its mixture with air from a non-volatile absorbent. The entering gas stream contains 30 mole percent acetone, and the entering oil stream is acetone free. Of the acetone in the air stream, 97% is absorbed, and the concentrated liqueur at the bottom has a total 10% mole acetone. The equilibrium relationship for this system is y equals 1.9x. I'm going to calculate and then show the operating line. I'm going to show the equilibrium line since it's given. I'm going to find the ideal stages off the graph, and I will find the number of ideal stages using the Kremser equation and then off the Kremser chart. First we need to create a figure. Boom, done. Not that hard. Assume 100 kilomole an hour feed gas. We're also going to assume no air is absorbed, and it tells us no oil is stripped. We'll label. K is equal to y over x, and I just put it in here because it was really simple, and that is equal to 1.9 using the equilibrium line. Yn plus 1 is equal to the mole of acetone over the mole of acetone-free vapor, which is the air, so that is 0.3 over 0.7, which gives us 0.4286. The amount absorbed is 97% of what came in, so that's 97 times the mole percent times the 100 assumed kilomoles an hour, which gives us 29.1 kilomoles an hour. They told us that the amount in the liquid, or the amount absorbed, is equal to 10% the total concentrated liqueur, so Ln is equal to 291 kilomoles an hour. The amount of oil in the liquid product is 90% of that, since 10% is acetone. Therefore, we get 261.9 kilomoles an hour of acetone-free absorbent. Since no oil is stripped, that means that is how much came in, so L naught is equal to 261.9 kilomoles an hour. Xn is equal to the amount of acetone in the product divided by the amount of acetone-free absorbent in the product, which is equal to 0.11. The amount not absorbed is equal to 1 minus the 97%, times the mole percent times the amount assumed, which gives us 0.9 kilomoles an hour. The total amount of vapor coming out is equal to the 70 air that came in times the 3% that is left, which gives us 70.9 kilomoles an hour. Y1 is found to be the amount of acetone in the vapor divided by the amount of acetone-free vapor, so it's 0.9 over 70 is equal to 0.01286. So we're going to put the numbers on the figures. We have the top point as 0 and 0.01286, and the bottom as 0.1 and 0.4286. We'll plot that. The orange line is the operating line, and the blue line is the equilibrium line. So what we're going to do is step off from the bottom, going from the operating line to the equilibrium line, then back up to the operating line, and so on and so forth, to find out the number of stages required. Here we have 4. It does cross over to get to 5, but we will round down since it does not take a full 5th operation to get to. So to use the Kremser method, we're just going to use A is equal to L over KV, where L is equal to L prime, which is the amount of acetone-free oil, and V is equal to V prime, which is the amount of acetone-free vapor, 70. So we get A is equal to 1.969. Since we have 97% absorbed, phi A is equal to the fraction not absorbed, which is that 3% left over. Phi A is equal to A minus 1 over A to the n plus 1 minus 1. Do a little bit of algebra, you get n is equal to 4.17. We will round this down again so that it equals 4, which is what we got from the graph. So we're going to use A and phi A to figure it out from the Kremser chart, which is this chart right here. So we're going to draw a couple lines. Oh, look at that. It's really close to 4. It's a little over, so we'll round down and have n is equal to 4. And that's all there really is.